Hello everyone, this is Cloud Computing and Big Data Analytics, session number 34, and I'm going to lecture on the topic Current Challenges and Trends in Big Data Acquisition. In big data, data needs to be analyzed to enhance decision making, but there are some challenges of big data encountered by companies. These include data quality, storage, lack of data science professionals, validating data, and accumulating data from different sources. The big data era brings huge challenges on data acquisition, storage, management, and analysis. Traditional data management and analytic systems are based on the relational database management systems. However, such RDBMS apply only to structured data. Some key challenges in big data management are as follows. First one is data representation. Many datasets have certain levels of heterogeneity in type, structure, semantics, organization, granularity, and accessibility. Data representation aims to make data more meaningful, which is useful for computer analysis and user interpretation. Also, an improper data representation will reduce the value of the original data and may even obstruct effective data analysis. Second one is redundancy reduction and data compression. Generally, there is a high level of redundancy in datasets. Redundancy reduction and data compression is very effective to reduce the indirect cost of the entire system on the premise that the potential values of the data are not affected. For example, most data generated by sensor networks are highly redundant, which may be filtered and compressed at orders of magnitude. Next one is data lifecycle management. Compared with the relatively slow advances of storage systems, pervasive sensors and computing are generating data at unprecedented rates and scales. One of the challenges is that the current storage system could not support such massive data. Generally speaking, values hidden in the big data depend on data freshness. Therefore, an important principle related to the analytical value should be developed to decide which data shall be stored and which shall be discarded. Next key challenge is analytical mechanism. The analytical system of big data possesses masses of heterogeneous data within a limited time. However, traditional RDBMS strictly lack scalability and expandability, which could not meet the performance requirements. Non-relational databases have shown their unique advantages in the processing of unstructured data and have become mainstream in big data analysis. There are still some problems with non-relational databases in their performance and particular applications. The next set of key challenge is data confidentiality. Most big data service providers or owners could not effectively maintain and analyze such huge datasets because of their limited capacity. They must rely on other professionals or tools to analyze the data, which increase the potential safety risk. For example, the transactional dataset generally includes a set of complete operating data to drive key business processes. Such data contains details of low granularity, some sensitive information such as credit card numbers. Therefore, analysis of big data may be delivered to a third party for processing only when preventive measures are taken to protect the sensitive data to ensure its safety. Next key challenge is energy management. The energy consumption of mainframe computing systems has drawn much attention from both the economy and environment perspectives. The processing, storage and transmission of big data will inevitably consume more and more electric energy. Therefore, system-level power consumption control and management mechanisms must be established with expandability and accessibility. Next one is expandability and scalability. The analytical system of big data must support present and future data sets. The analytical algorithm must be able to process increasingly expanding and more complex data sets. And the last key challenge is cooperation. Now, analysis of big data is actually an interdisciplinary research which requires experts in different fields to cooperate to harvest the potential of big data. A comprehensive big data network architecture is necessary to help scientists and engineers in various fields across different kinds of data and fully utilize their expertise so as to cooperate to complete the analytical objectives. Next is, what is data acquisition in big data? Data acquisition, it has been understood as the process of gathering, filtering and cleaning data before the data is put in a data warehouse or any other storage solution. So we need to gather, filter and also clean the data before storing it in a warehouse. And we all know that the acquisition of big data is most commonly governed by 4, and now it's the 5 V's: volume, velocity, variety, value and veracity. The bulk of big data generated actually comes from 3 primary sources: social data, machine data and transactional data. So in this session we have learned about the current challenges in big data and also the trends in big data acquisition. These are the references. Thank you. This is Pavitra signing off.